Let's go ahead and review acceleration, velocity, and position and how it relates to integration. We'll do this before we attack some pretty long word problems. So the integral of acceleration, I'm going to put in dt because remember we are integrating with respect to time, t is our variable, is going to be equal to the velocity function. It's a little oversimplified and I'll tell you what I mean in a second. But we should also recall that the integral velocity function is going to give us our position function. And we've used h of t and s of t and a couple of variables to do position. But in this video, let's go ahead and keep it as an s. S means position. All right. So let's start by looking at our first problem. The acceleration of Mr. Amundsen on his snowmobile is 90 feet per second squared. Let v of t, velocity, represent the velocity of Mr. Amundsen at time t, and we're talking about time being in seconds. Assume that s of 0 equals 0. This means assume that at time equals 0, our starting position is 0. Remember, s is for position. And v of 0 equals 0, meaning that we're basically starting from a stop. Right, where our time at time 0, our velocity is 0, meaning we're not moving at the start. So how far does Mr. Amundsen travel in the first 6 seconds? Well, what we're really looking for, how far does Mr. Amundsen travel, is we're looking for s of 6 minus s of 0. This would be his position at time 6 minus his position at time 0. All right, so how are we going to find the position function? Well, we're given the acceleration is 90, so I can go ahead and I can write that the integral of 90 dt is equal to. This is literally my acceleration function, so the answer that I get here is going to be my velocity function. Well, of course, this is a 90 t plus c. So my velocity is going to be 90 t plus c. But we were also told that velocity was equal to 0 when your time was 0. So we can solve for c. So I'm going to basically plug in 0 for t. All right, times 0. So we're going to have my velocity, which is going to be v of 0 is equal to 0. So I'm going to have 0 is equal to 90 times t, which is going to give me 0 plus c. Well, that's going to give me 0 equals c. So what have I just found? I've just found that my velocity function is equal to simply 90t, and we just found that the c is 0. Now, is this going to be true whenever velocity of 0 equals 0? Yeah, it is. Basically, you're going to have 0 as your plus constant term. All right, now what are we going to do? Well, I have velocity, and I need to find the position function. So now I'm going to integrate my velocity function, or 90t dt, and that's going to give me my position function. So when I integrate this, I get 90t squared over 2, which is, well, and a plus c, right? Which is actually going to be 45t squared plus c. All right, now, we also know that our s of 0 is equal to 0. So what did we just find? Well, that was the position function, is 45t squared plus c. Well, we know that s of 0 equals 0, so I can replace my t with 0. Okay, so I'm basically getting s of 0, which I know to be 0, is equal to 0 plus c. In other words, this c value right here is 0. So I can erase that plus c because I just found that my c is 0. And I can state that this is my position function. So now to find my position, just like I said in the very beginning here, I'm going to do s of 6 minus s of 0, meaning what's my position at time 6 and what's my position at time 0. So I'm going to have 45, and then I'm talking about first 6 seconds, so it's going to be 6 squared minus 45, and then at time 0. Okay, well that's going to give me 36 times 45, which gives me 1620, and then obviously it would be a minus 0. So we're at 1,620 feet have been traveled. So if I were to kind of condense this particular problem, just know that we start off by integrating our acceleration function. This right here is acceleration, and that gives us our velocity function. Here we get our velocity function, which we find out that we have our plus c is 0 because it's starting from stop. And I take my velocity right here and integrate it, and it gives me my position function right here, which I simplified to be here. Again, I found that my plus c was 0 because of these two facts, specifically this one helped. All right, once I had my position function right here, I plugged into it the value of 6 because we're at 6 seconds minus our original 0 seconds. And that's our answer. All right, next problem says the acceleration of Miss Sorensen on her quad is given by acceleration of t equals 10 square root t, where t is in seconds and a of t is in feet per second squared. Assuming velocity of 0 equals 0, what's the velocity of the car at 9 seconds? Okay, well, we're given acceleration and we want to get to velocity, so we're going to integrate 10 square root of t dt. I'm going to just go ahead and simplify this as 10t to the 1/2. And I'm going to use my power rule where I add 2 over 2, or 1, to that. So that's going to give me t to the 3/2. Because if I add 2 over 2 here, that gives me a 3 over 2. And now I'm going to multiply by its reciprocal, because I'm dividing by that fraction. So I'm going to have times 2/3. But don't forget about this 10. So that's going to give me 20t to the 3/2 over 3 plus c is equal to my velocity function. Now, we are also told that the velocity is 0 when our time is 0. So if you want, we can just plug right in. So we're letting t be equal to 0 here and velocity of 0 equal to 0. So this becomes a 20 0 to the 3/2 over 3 plus c equals, well, 0, right? Because we're saying our velocity is, putting in a 0 here, and we're putting in a 0 here. All right, so what does that give us for our c value? Well, this is very uneventful. It's exactly what you think it would be. We get a 0 plus c equals 0, meaning c equals 0. So our velocity function is actually going to be plus 0 right here, plus 0, so I can just eliminate this. So now the problem says, what's my velocity at 9 seconds? Well, if this is equal to my velocity function, then velocity of 9 is going to be equal to plugging that straight into the function. So that's going to be 20 times 9 to the 3/2 all over 3. So let me do that. I get 180. Now let's think about what the units are going to be. In this case, we're talking about feet per second squared, so this is going to be feet per second. Alrighty, that's our answer. This is our velocity function, and we just plugged right in to get our final answer. One more question, y'all. All right, good old Peggy. Gotta love Peggy. is stopped at the top of a steep hill in Seattle as her traffic light turns green, her car rolls backwards a little bit before moving forward. If her velocity is given by this function, what's her displacement? Displacement really means like how far has she traveled. So for example, if I go to school, I walk 10 miles to school, and then I actually walk 10 miles back, believe it or not, my displacement is actually 0. My distance traveled is 20, but my displacement is 0 because I haven't gone anywhere. That's not super important for this, but just some vocabulary you should be aware of. All right, well, we're trying to find displacement, which talks about position, where she was at the start of 0 seconds versus at 2 seconds. So I'm going to integrate velocity to get my position function. So I'm going to have a 10t squared minus 8t dt. Okay, I'm going to integrate that. So that's going to give me a 10t cubed over 3 minus 8t squared over 2. And I can go ahead and put my plus c, but we actually know that she was stopped at the beginning, which means that we can say that her position is at 0 at the beginning. So really our plus c doesn't matter at all. So how can I go ahead and simplify this? This is going to be a 10t cubed over 3 minus 4t squared, because I just did minus 8 divided by 2. Now, you can think of this right now as calculating a definite integral from 0 to 2 seconds, or you can just think about it as plugging in 2 and then plugging in 0, because you're trying to figure out where was she at 2 seconds, where was she at 0 seconds. Okay, so at 2 seconds, I get 10 times 2 cubed over 3 minus 4 times 2 squared. Now I'm pretty confident when I plug in 0 here, I'm just going to get a 0 for this whole gosh darn thing when I plug in 0. That's so nice when that happens. All right, going ahead and doing this math, 2 cubed is obviously 8. So this is going to give me 80 divided by 3. And then this becomes minus 16 because 2 squared is 4 times 4 is 16. So 80 divided by 3 minus 16 gives me 10.667. And this will be in feet, right? Because of, where does it say it? I guess it doesn't say anywhere. That's all right. You can always ask me a question. Hey, is this feet per second? Is this meters per second? Etc. So our final answer is that over those 2 seconds, you traveled or gone a displacement of 10.667 feet. Okay, so quick summary on this. If I ask you for displacement, you are finding your position function and you are plugging in both values of time equals 2 and 0 into that. If I ask you for the velocity, you integrate acceleration and then plug into your velocity function. If I ask you for how far does Mr. Amsden travel, you are going to find your velocity function, then find your position function, and then you're going to plug into that your beginning value and your end value. Okay, thanks for watching, everyone.